Hello friends, welcome to the channel Total Output Power Solutions. Now in this video we are going to discuss about the maintenance management, and in the maintenance management we are going to discuss about preventive maintenance system or preventive maintenance. Well, I am Manohar Tatvavadi and from Total Output Power Solutions. So we will discuss about the following agenda: the definition of preventive maintenance, then the reasons for the increased need of preventive maintenance, advantages of a preventive maintenance system, risk of running a preventive maintenance system, when to use a preventive maintenance system, the law of preventive maintenance, guide to a successful preventive maintenance system, execution processes, then conclusion and summary. So with this agenda, today's agenda, we will discuss further. So the definition. Now what is preventive maintenance? Preventive maintenance is a schedule of planned maintenance actions aimed at the prevention of breakdowns and failures. The primary goal of preventive maintenance is to prevent the failure of equipment, plants or systems before it actually occurs. It is designed to preserve and enhance equipment reliability by replacing worn components before they actually fail. The preventive maintenance activities. So what are the preventive maintenance activities? Preventive maintenance activities include equipment checks, partial or complete overhauls at specific periods, oil changes, lubrication and so on. In addition, workers can record the equipment deterioration so that they know to replace or repair worn parts before they cause the system to fail. Its purpose is to minimize breakdowns and excessive depreciation. Neither equipment nor facilities should be allowed to go to the breaking point. In its simplest form, preventive maintenance can be compared to the service schedule for an automobile. If the automobile is not maintained properly, it might break down at an unexpected time. Likewise, when the machinery in a firm breaks down unexpectedly, it could result in lost business and halts in production, which could be very costly. The main reasons for the need of a preventive maintenance system. The reasons: first is the increased automation, then losses due to production interruptions, delays. The production of a regular, reliable, higher quality product, quality may be hampered. Just-in-time manufacturing or delivering services. Stores management, increased cost of spares. Need for a more organized plant environment. Increased automation of production facilities has caused a higher need of a preventive maintenance system for a successful and continuous flow of activities. A halt in process would cause business losses due to production delays. Since production delays will have an adverse effect on just-in-time manufacturing or services, the need for a preventive maintenance will be vital in such an environment. The advantages of a preventive maintenance system: reduced production downtime resulting in fewer machine breakdowns, that is the result of proper maintenance of the equipment. Then better conservation of assets and increased life expectancy of assets, thereby eliminating premature replacement of machinery and equipment. Example: when a car is maintained properly, it would run smoothly. If not, it would start causing problems halfway through of its life cycle. Then timely routine repairs circumvent fewer large-scale repairs. The routine checks and repairs would be less expensive than large-scale repairs, which would require intensive repairs causing longer system breakdowns, then reduced downtime and hence reduced cost. The store's management will be at its best. So these are the advantages of a preventive maintenance system. The further advantages are reduced cost of repairs by reducing secondary failures. When parts fail in service, they usually damage other parts. That is the secondary failure. So that will be lesser. Better quality products. Reduced product rejects, rework and scrap due to better overall equipment condition. Identification of equipment with excessive maintenance cost. This would indicate the need for corrective maintenance. It is a maintenance technique which takes a reactive approach. Corrective maintenance means the comprehensive operator training or replacement of obsolete equipment. Then improved safety and quality conditions. Consumer satisfaction because of reduced failures or breakdowns. So these are the main advantages of the preventive maintenance. The risk of running a preventive maintenance system. Now this is a brainstorming exercise. We will just ask some questions. Are there any risk of running a preventive maintenance system? If there are risks, then when it would be better good time to use the preventive maintenance? Here I would like you to name some of the risks involved in running a preventive maintenance system. Let us brainstorm for a while and try to get different and out of the box answers. Once you name some of the risk, weigh the risk with the advantages and name some solutions where a preventive maintenance system would be advantageous for a firm. This video is specifically for the interaction with you. Therefore, give your time to come up with creative ideas and put them in the comments. Please. Now the risk. The potential errors or damages due to preventive maintenance. It may damage an adjacent equipment during a preventive maintenance task. This kind of errors might occur due to accidents such as oil leaks, reconnection errors, etc. Reintroducing infant mortality by installing new parts or materials. Every time new parts are being installed, the equipment goes through the infant stage where it will either fall, fail or succeed. This uncertainty of the new part of working properly is referred to as the infant mortality. Since introduction of a new part reintroduces infant mortality to that particular equipment or system, it is considered as a potential risk of preventive maintenance. Damage due to an error in reinstalling the equipment into its original location. A lot of errors that occur due to preventive maintenance occur as a result of errors in reinstalling the equipment into its original location. Also, you must have come across such situation where you had taken something apart and was not able to put it back to its original position, original form. So those are the risks. Now a real life example of a preventive maintenance error. A review of the data from fossil fuel power plants that examined the frequency and duration of forced outages after a planned or forced maintenance outages reinforces our point. The data collected from those plants showed that of 3,146 maintenance outages, 1,772 of them occurred in less than 1 week after a maintenance outage. Now clearly this is a pretty strong evidence that suggests that in 56% of these cases, unplanned maintenance outages were caused by errors committed during a recent maintenance outage. You also might have been involved in such situation. So, when it make a sense to implement the PM is preventive maintenance, when would it make sense to implement the preventive maintenance? That actually it is rather not a theoretical one, but it's a practical question. So when does preventive maintenance make sense? Now this is a logical choice that considers two conditions. The conditions are the component in question has an increasing failure rate. The preventive maintenance should be implemented when and only when the equipment or the component under consideration has an increasing failure rate, which means the failure rate should increase with time, implying wear out. Preventive maintenance of a component that has a constant rate of failure would not be sensible, because such components could be replaced without the implementation of a preventive maintenance system. We can just replace such components just by monitoring the duration of use, since it has a constant failure rate. The second is, the overall cost of the preventive maintenance action must be less than the overall cost of a corrective action. In the overall cost for a corrective action, one should include ancillary tangible or intangible costs such as downtime cost, loss of production cost, lawsuits over the failure of a safety critical item, loss of goodwill, etc. Now, if both of these conditions are met, then the preventive maintenance would make sense. Now, the law of preventive maintenance. Higher the value of the plant assets and the equipment per square foot of plant, the greater will be the return on a preventive maintenance program. This is the law actually. Now we can get some example on this. Downtime in an automobile plant assembly line at one time cost rupees 8 lakhs per minute. Relating to this, to lost production time, an automobile manufacturer reported that the establishment of a proper preventive maintenance program in their 16 assembly plants reduced the downtime from 300 hours per year to 25 hours per year. Now, with results such as this, they can very well afford to develop a preventive maintenance program. However, keep in mind that no matter how big the value of the assets would be, in order for the preventive maintenance to be successful, you need to fulfill the two conditions mentioned earlier. It is important to remind about those 2 points, because those 2 points basically decide whether or not to implement a preventive maintenance program. Now, how to determine the optimum age of replacement? We have a graph here which is showing you cost per unit time versus time. You see here the three graphs, that one is the corrective replacement, preventive replacement and minimum cost of replacement. So the above diagram shows the cost per unit time versus time. In this figure, it can be seen that the corrective replacement cost increases as the replacement interval increases. In other words, the less often you perform a preventive maintenance action, the higher your corrective cost will be. Obviously, the longer we let a component operate, its failure rate increases to a point that is more likely to fail, thus requiring more corrective actions. The opposite is true for the preventive replacement cost. The longer you wait to perform a preventive maintenance, the lesser the cost. While if you do preventive maintenance too often, the higher the costs. So if we combine both these costs, we can see that there is an optimum point that minimizes the cost. In other words, one must strike a balance between the risk, that is cost, associated with a failure while maximizing the time between preventive maintenance actions. So there you can determine exactly the time. So how to determine the optimum age of replacement? A more technical approach, you have a more technical approach to that, wherein you can put in the values in the equations, those are provided, and the optimum replacement time can be found by minimizing the cost per unit time, CPUT. By solving T on the above equations, you can find the optimum replacement time interval that you can find out. You can put in the values RT, CP, CU and CPUT T, the optimum replacement time you can get. So this is a theoretical equation for that. You may use that to get the optimum age of replacement. the key for a successful preventive maintenance system. The key is you should have the proper scheduling. It should be automated to the maximum extent possible. So priority should be given to preventive maintenance, and a very aggressive program to monitor the schedule and ensure that the work is completed according to schedule should be in place. If the scheduling of preventive maintenance isn't sorted out properly, it could cost the firm a great deal in lost sales plus an inefficient preventive maintenance program. Therefore, through automation, you can make sure proper maintenance takes place in due time. Then the execution. It should be done before the actual breakdown occurs. Without proper execution, the preventive maintenance program will not provide the desired results, which would result in the same consequences as a failure in scheduling. So these two are that is the key for successful preventive maintenance system. Now we have a bathtub model. We can discuss about it. The bathtub model, there are three stages of new parts. The infant mortality stage, a fairly long run stage, and the wear out stage. Here in the graph also you can see. The traditional view according to bathtub model is to replace the components just before they enter the wear out stage. So reliability specialists often describe the lifetime of a population of products using a graphical representation called the bathtub curve. The bathtub curve consists of three periods: an infant mortality period with a decreasing failure rate, followed by a normal life period, also known as useful life, with a low, relatively constant failure rate, and concluding with a wear out period that exhibits an increasing failure rate. So this is the bathtub model. Here you can see the infant mortality, normal life, and the critical life. The traditional view says wear out life. The wear out stage, that is the equal to the increased rate of failure. So point to discuss and ponder, say get on the point. Since wear out stage represents the increased rate of failure, wouldn't it be reasonable or plausible to execute the preventive maintenance program at this stage? Now earlier we discussed of the two conditions for considering a preventive maintenance system, one of which was to have a increasing rate of failure. So would it be practical to use a preventive maintenance system every time a component has an increasing rate of failure? You can take some time to think over. This is not a theoretical question, but a practical implementation of preventive maintenance. Theoretically, every time there is an increasing rate of failure, it would be best to use the preventive maintenance. But would it be so practically? Now the execution. One example of this is United Airlines research, reliability centered maintenance based on research done by United Airlines and the rest of the aircraft industry showed that very few non-structural components exhibit bathtub curve wear out characteristics. Their research showed that only about 11% of all components exhibit wear out characteristics, but 72% of components do exhibit infant mortality characteristics. So these same characteristics have been shown to apply in Department of Defense systems as well as power plant systems. So if we just decide to take a traditional approach to the preventive maintenance, it would be advisable to use the preventive maintenance during wear out stage. But according to research results presented, it seems like failure could occur at a point of an equipment's life cycle. So the next question would be, what can be done to overcome and ensure good preventive maintenance system? That is a question coming in our mind. So what really should a preventive maintenance focus on? The preventive maintenance should focus on the cleaning, lubrication and correcting deficiencies and this can be found through testing and inspection only. So predetermined parts replacement should be minimal and done only where statistical evidence clearly indicates wear out characteristics. In order for a successful preventive maintenance system, the system should focus mainly on cleaning, lubrication and correcting deficiencies that are found through testing and inspecting the equipment. Without proper testing and inspection, it would not be possible to decide whether to implement a preventive maintenance program or when to implement it. For cost reduction purposes and efficiency of the program, it's vital to keep the predetermined part replacement to a minimal and done only where statistical evidence clearly points out the wear out characteristics. If the components are not yet in a wear out stage, it's best to continue with a preventive maintenance system to extract the maximum life from it, given that the component has an increasing failure rate and the cost of the preventive maintenance is less than the corrective control. So this should be focus of the preventive maintenance. Now in absence of data, what you should do? So in the absence of data, you should do with the age exploration programs. When the prior data is absent to make the decision on a preventive maintenance, a firm should engage in age exploration programs to determine life expectancy. Find out the critical times in component life cycle, comparisons with similar products to identify the problem points of the component. The statistical analysis. The use of statistical methods to decide when to implement a preventive maintenance system. This requires the action of an age exploration to collect the data that is needed to come with the analysis. But when prior data is absent, implementing a preventive maintenance system would be more costly because of the money that needs to be spent on the information collection. However, if a company decides not to implement the preventive maintenance just because of the extra cost, it is very likely that they would incur more costs as a result of sudden system breakdowns. So cost shouldn't be a primary factor in deciding against the data collection for a preventive maintenance system. Now motivating the preventive maintenance workers. This is also important. The training programs, they are most effective. Then establish inspection and preventive maintenance as a recognized important part of the overall maintenance program. Then assign competent responsible people to the preventive maintenance program. You can also discuss and come out with some of the motivational elements that could be implemented to ensure that the preventive maintenance program is being valued by employees. Also discuss the importance of each of these motivational factors and how they should be applied, and emphasize the importance of a motivated set of employees for a successful preventive maintenance program. Now follow up to assure quality performance and to show everyone that management does care. Provide training in precision maintenance practices and training in the right techniques and procedures for preventive maintenance. On specific equipment, set high standards and publicize reduced costs with the improved uptime and revenues which are the result of effective preventive maintenance. This summary. The preventive maintenance is not difficult to achieve. It is an essential part for cost reduction. There is an element of risk involved in preventive maintenance. Careful planning and execution will reduce the risk of preventive maintenance. The biggest benefits of a preventive maintenance program occur through the painting, lubrication, cleaning and adjusting and minor component replacement to extend the life of equipment and facilities. So this is the summary, and with that, that's all falls from Total Output Power Solutions. Well, thanks for watching. Please comment, like, share and subscribe our channel Total Output Power Solutions. I take your leave, Manohar Tatvavadi from Balewadi, Pune. Thanks.